So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on verification of Hooke's law. This is the experimental setup you can see. So before going to start, if you are new to my channel, please subscribe my channel and press the bell icon for notification so that you will have the information regarding upcoming videos. So let us start. So here the aim of the experiment is to verify the Hooke's law. As we know, according to Hooke's law, stress is directly proportional to strain. Okay, we can write in terms of the expression force is directly proportional to the extension, nothing but applied force is proportional to x. If we remove the proportionality constant, we will have the constant k, that is force constant. So we have to verify the Hooke's law. So just read the theory behind that, and this is the way how the diagram looks like. Okay, we need apparatus, scale, spring, pointer, pan to put the weights. Okay, this is already set up here. You can see spring, scale, and these are the weights we have to use. Then observations you should note down here. Length of the spring, so you should measure the length of the spring using this scale here itself. So it is around 12 centimeter. Least count of screw gauge, so already you are familiar with screw gauge measurements, so 0.001. Then diameter of the spring, you can measure using that also by scale. So you have to take it here d1 and d2, two times you have to measure and take the average, that you will have the diameter. It is around 0.8165. So radius of the spring, if we know the diameter, then you can calculate the radius. Then area, if you know radius, you can calculate area of the spring. Pi r square is equal to 0.0271 centimeters. Okay, then procedure here I can explain. First, what you have to do, you have to suspend the spring from the spring stand already suspended and attach the pointer and the hook with the pan to the end of the spring. So just you can use this pan, weight pan here. So you have to attach it to this spring. Okay, just I will show you how to attach that. Okay, I will attach this weight pan to the spring. You can just see it, length is going to increase, and then place the ruler vertically to the stand such that the pointer corresponding to a readable making on the ruler. You can just read this is the pointer, so for that you can measure the reading. Note the initial reading of the pointer against the ruler. What is the initial reading? Just you can note down and place this is known weight. Okay, that is about 50 gram. Each time you have to increase the weight. So then note down the displacement x from the pointer. Then this is the first reading you can note down. So they have written here, you can see for 50 19.5. just you can see here it is exactly 19.5. just it must be constant, you should not move. You can see 9.5 for 50 gram. Then similarly repeat the procedure for 100 gram. Each time you have to increase 50 gram. And then note down the reading. For 100 gram how much you will get the reading, scale reading you should write. Up to 250 gram you can take. Next what you have to do, you have to just decrease the weight. 250, 200, 150 and 100. So we have to just remove the weight. And then you have to note down the reading. There is a small variation, so just take the average of reading 192, that you will have the mean a1, a2, a3, a4, a5. Okay, then after measuring this mean, extension you can calculate, that is you have to subtract reading a1 in itself, then you will have the first reading 0, then next a2 minus a1, like that you have to repeat, so that you will get the extension, how much the spring has extended. Then formula to calculate force, that is m mass into gravity, mass 50 to about 250, so g is gravitational constant, just you can multiply and you will get the force. Then stress, as we know, stress formula is force by area. Once you calculate the force, then you can calculate stress. Already area has been given in observation, put the value, you will get the stress, corresponding stress. Then strain, as we know, formula for strain is change in dimension to the original dimension, means change in length, that is L, extension, and the original length as we have measured in the observation, that you have to use and calculate the strain. So once you plot the graph of stress versus strain, you will get the straight line. That means as stress increases, strain is going to increase. So stress is directly proportional to strain according to Hooke's law. So from this experiment we can verify Hooke's law. So this has been verified. So this is all about verification of Hooke's law. Thank you.